Okay, boleh dengar eh? Can you guys hear me? Okay, let's wait for another 5 minutes before we start. Okay, let's wait for your friends. Okay, we have 70 students now. Okay, let's wait for another 10 student. Okay, because I'll be recording this session, so um, the video I have to make it if you see my camera, okay, it's supposed to be my photos, but it's a slide because this one is from recording. Okay, I guess this is the only person that will be joining us today. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning. Okay, so today, actually, I supposed to make the video last week, but unfortunately, I had a very bad health problem. So I could not stand quite long for the lecture for today, and I'm also at home because of my condition right now. Okay, so hopefully it will not interfere with our session. So hopefully you guys are okay in the university, and hopefully you guys can hear me very well. So mic check first. Can you guys hear me?
Yes.
Okay, okay,
Yes, doctor.
okay, 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 good. So let's continue our class here for today. Okay, so today it will be our class will be for about transport layer. Okay, transport layer is from the bottom. Okay, we have the hardware we have the Ethernet layer, and then the we have the sorry we have the physical layer, and then we have the data link layer, and then we have internet layer, and then we're going towards one step uh, above, which is the transport layer. Okay, so transport layer, okay, when we look at into transport layer, it involves the transportation of data. So what exactly the transportation of data? If you look back, okay, into the slide, Okay, transportation of data means that okay, it involves the process of transport of the data between the application layer and also the internet layer. You know that internet layer where you assign your IP address, you assign your destination and source IP address. Okay, before they being inside to MAC address and everything. Okay, so transport layer, okay, is the one that will help bridge between the application and also the IP protocols. So the transport layer basically responsible for logical communication between application running on different hosts. So means that we have a lot of application that run a different kind of software. So how exactly they assign those data into the IP packet properly, even though that there are different types of data involved. So the link between the application layer and the lower layers, okay, they are the transport layer is the one that are responsible for the transition, okay, within the network transmission. Okay, so basically, how did they work? Okay, they have this responsibility. So basically, they track individual conversation. Okay, and then they segment data and resemble the segments. So means that when they want to send, they will segment the data in case the data is huge, and they will reassemble segments when the data is received by at the destination. Okay, so they also add header information which involve the part of separation within the segment, and then they identify, separate, and manage multiple conversation, and they use segmentation and multiplexing to enable different communication conversation to be interleaved on the same network. So this is basically what the transport layer do. Okay, as you can see, in case this is a computer and he is receiving, okay, and transmitting data. Okay, so here in this case, you see that we have an email, you have messaging, multiple web pages, online video chatting, and streaming video. Okay, so now what you're doing is that you want to send data towards outwards. Okay, in this case, segmentation, okay, is needed so that it can multiplex all this data and send them at the same time. Means that all this data that you are using right now, okay, they cannot send it one by one. In case that, for example, if you send email, if you say one by one, if you send email or messaging somebody, you cannot watch a video. But now you see that in your computer, you can do all of them at once. So this is because of multiplexing. They mix all those data according to the segmentation of those data, and they add it like okay, some of them streaming again, they alternate it with web pages information, messaging, and then continue with next segment. So segmentation means that they split the data in a small chunk so that they can send it a little bit by a little bit into the destination itself. So let's take a look at the protocol involving transport layer. Okay, before this, we have the network access layer where you have the data link and also the physical layer here. You see that the network access layer involve LAN connections and WAN connections. And from this, they are the one who transmit all those IP packets towards your network. Okay, so IP packet, these are the one that assign the IP addresses for your host and destination. In case you don't have the internet, okay, the IP packet will not work because you cannot send it because you don't have the destination and also the source and destination IP packet, IP address. So before they being sent and assigned IP addresses, okay, the transport layer will decide what kind of data and what kind of protocol to be managed and be assigned to become the IP packet. Okay, so the IP basically they does not specify how the delivery works. Okay, they just assign the source and the destination, but they don't decide how actually to deliver the parcel. In case you think about your online shopping, some of the things are very, very important things. Okay, means that the delivery guy has to get and obtain your signature when they deliver your items. Okay, but some of them, like for example, letters, for example, they are not important. So the delivery guy can just leave it into your mailbox. Okay, So there are two types of delivery, which is the TCP and UDP, TCP protocols and UDP protocols, and both of them, okay, they manage different kind of data. Okay, so based on this protocol, okay, address will be assigned and become IP packet, and then they will send it towards your network. So how exactly they work? Okay, let's take a look at the first one, which is the TCP protocols. Okay, so 3CP protocol is what we call a transmission control protocol. So transmission control protocol, they provide reliability and flow control. So what is important with TCP is that TCP operation involve numbering and tracking. Okay, the data segment transmitted to a specific host from a specific application. So means that if you see numbering and tracking, you got an idea. If you do some online shopping, you got the tracking number. Okay, which you can track later on in the internet. Okay, you can call the delivery service whether the parcel is on the way or not. Okay, so TCP protocol involve those kind of process. So when a person has received, okay, a destination has received the data, he will send a response which is known as acknowledgement. Okay, they will acknowledge they have received the data. Okay, in case they did not receive the data, what will happen is that, okay, in case they did not receive the data, what will happen is that the sender will retransmit any unacknowledged data after a certain amount of time. Means that he will wait, the sender will wait, okay, whether he got a response, whether the data has been received or not. If he didn't receive any acknowledgement or response from the destination, he will retransmit again the data towards the destination. Okay, so some of the data, okay, in case when you send data, okay, you send 10 parcel, and this 10 parcel, okay, 10 segments, basically we call it segments. Okay, so when we send the segment from 1 to 10, suddenly segment number 5 did not receive by the destination, so they did not provide an acknowledgement towards the sender. So what happened here? Okay, the sender will try to send again parcel number 5, and now you see that the order is wrong. So from 1 to 10, instead you have 1, 2, 3, 4, 6, 7, 8, 9, 10, and 5. So TCP protocol at the destination, he will refer to the header in the segment, okay, which is involving the order of the data, and he will reassemble again the sequence, okay, the segments, and reassemble all those data so that it can be processed by the receiver. Okay, so when you send a data, okay, when you send the data, so it can send at efficient rate, okay, and at the acceptable by the receiver, because it waits for the acknowledgement. So like for example, if when a delivery guy want to send parcel to you, he call you first, and then whether you at home or not, okay, and then we pass it to you, got a response, and then the process is done. So same thing at TCP protocol, he will keep asking the destination whether is okay to receive data or not, or is have we received the data or not. So this kind of process will be a little bit slower, but it is efficient to make sure that all those data being sent accurately, efficiently. uh, most important is all the data can be received by the receiver as intended by the sender. Okay, next protocol is what we call a user datagram protocol. So this one is what we call UDP protocol. So the UDP provides the basic functions for delivering datagrams between the appropriate application with very little overhead and data checking. This is the point here. You see that TCP, they do a lot of overheading and a lot of data checking to confirm whether the data has been sent or not. However, UDP, okay, it almost no data checking involved. Okay, so UDP is basically is a connectionless protocol. It doesn't need connection between the sender and the receiver. Okay, the destination, sender and the destination. Okay, source and destination basically. So when it's sent, okay, it just send it towards the network, okay, without requirement of acknowledgement by the destination. So this is known as a best effort delivery protocol because no acknowledgement, okay, that the data is received at the destination is provided to the user. Okay, so now, okay, when you look at this figure here, okay, a file is sent to the server using a Trivial File Transfer Protocol (TFTP) application. UDP divides the data into datagram and send them using best effort delivery. So this is sending the data immediately directly towards the server without needing of acknowledgement. So let's take a look. So let's brainstorm in this case. Okay, so what happen if you use UDP instead of TCP in certain cases? Okay, like for example, if you look at videos, online videos with UDP protocol and TCP protocol or TCP protocol, what are the different that you can find in those protocols? Anybody can answer me? Panggil lah siapa-siapa. What is the different? Okay, like for example, you are looking at into video online. Okay, if the protocol is using UDP and another protocol using TCP, what kind of differences you can expect in the video? Anybody can answer? Iqbal. Iqbal, you know what is different?
Sorry, sir. Can you repeat?
Okay, the question is that, okay, if you are looking into an online video, okay, when the online video that you watch it, okay, you watch the online video, okay, if the video using TCP protocol or UDP protocol, what are the different in the quality of the video? So like I mentioned, TCP, they need connection. Okay, they need response from the destination, but UDP, they doesn't need connection, doesn't need response. Okay, of course, if you look at into an online video, what are the difference between TCP and UDP?
Doctor, can I answer?
Okay, Iqbal lambat. Okay, Isham. Okay, what is the difference?
Yes, UDP is better because it will not wait for response.
Okay, we'll not wait for response. Okay, there's one answer. Okay, anybody else? UDP is better. Uh, but actually, both can be better in one case. Okay, so what exactly happened to the differences between the two videos? Anybody else got an idea? Iqbal, disconnect dah.
Sorry, sir. Tadi problem sikit.
Okay.
What was the question again?
UDP and TCP, bila tengok YouTube video, when you look at into a video online lah. Okay, when you look at into video online, that video when it use UDP or TCP, what are the difference in the quality?
Uh, mm, I think
You think what? Disconnect already.
no, no, no.
Okay, Hisham is raised hand. Okay, never mind lah. I go straight forward to the
Uh,
answer lah. Okay. For TCP, okay, for online video, usually you might encounter what you commonly known as buffering, right? You guys know about what buffering, right? Because it's going to buffer to make sure the connection, data, everything has been sent and received so that the video can load properly without anything missing. However, for UDP, when the data is missed, okay, you might find out it as a lag. Okay, a lag. So how come it become lag? Okay, you try to look into like online phone videos. Online phone videos. Online means that like in case even like in this Google Meet. Okay, if you have network disturbance, you will miss what I was talking, right? Like what Iqbal just experienced just now. Okay, it will be disturb. Okay, cut because some of the points have been interrupted by some of the errors there. However, with TCP, okay, TCP will correct those errors. Okay, UDP, they don't correct those errors. They just make sure that the data will flow immediately, even though there will be some interruption in the data. Okay, so this is different between TCP and UDP. So if TCP buffering, UDP, you got video lagging and suddenly jump into another place. Okay, so this is the difference between the quality of video that happening between TCP, between TCP and UDP. Okay, so let's take a look at the type of UDP and TCP and the effect on your application. So you need to choose the right transport layer protocol for the right application. Okay. So like for example, UDP, okay, we are usually using them for our IP telephones and also for our DNS, okay, domain name resolution. And for TCP, we are usually use them for our web, World Wide Web, and also for our email. So what happened? Why do we need to use UDP for our IP telephone? Is because we want it to hear in real time so that you can respond immediately what the other side was talking to you. So as much as possible, you want it to be sent as fast as possible. Okay. So means that they don't have much time to check whether the data has been set or not. If they are checking it, so means that the person who will be responding will be quite late in responding the messages or the talking that you are speaking within the telephone. So that's why we use UDP for telephones. And for TCP, okay, we use in World Wide Web because we want all the website can be loaded fully when you want to utilize them. Okay, especially in terms of application. Okay, any application, web application involved. So UDP, okay, is basically they used by request and reply application where the data is minimal and retransmission can be done quickly. Okay, if it is important that all the data arrives and that it can be processed in its proper sequence, TCP is usually the best as the transport protocol. Okay, so let's take a look at TCP. So the TCP features, basically they have four features. Okay, four main features. The first one, they need to establish a session. They need to ensure reliable delivery, and then they need to provide same order delivery, and they must support the flow control. Okay, so when they establish a session, okay, basically TCP is a connection-oriented protocol that negotiate and establish a permanent connection between source and destination device prior to forwarding any traffic. Okay, and for reliable delivery, okay, for many reasons, it is possible for a segment to become corrupted or lost completely as it transmitted over the network. TCP ensures that each segment is sent by the source arrive at the destination. And then we have provide same order delivery because network may provide multiple routes that can have different transmission rate. Data can arrive in the wrong order. Okay, so means that in TCP features, they can send it, they can rearrange them so that the data can arrive at according as the same order when they want to deliver. And next is support flow control. Network hosts have limited resources, like for example memory and processing power. So when TCP is aware that these resources are overtaxed, it can request that the sending application reduce the rate of data flow. This is the special things about the TCP. Okay, for the TCP protocol, you can see that this is the TCP header. Okay, this is the TCP header. There are 32 bit 32 bit wide and 20 bytes long. Okay, top to bottom. So here you can see that. Okay, here is the header here. Okay, you can see that we have a source port, destination port, sequence numbers, acknowledgement number, header length, reserve, control bit, checksum, window, urgent options, and then we have the data here. Okay. So TCP is basically a stateful protocol, which means it keeps track of the state of the communication session, so that all of this information need to be recorded and then be sent back. Okay, so that the TCP protocol can check whether the data being sent or not, and it must be acknowledged by the destination. Okay, so you have 16-bit for source port, 16-bit for destination port. Okay, and then you have sequence number 32-bit. Okay, acknowledgement number 32-bit, header length 4-bit, reserve 6-bit. Okay, and then control bit 6-bit. Okay, window size 16-bit, checksum 16-bit, and urgent for 16-bit. Okay, so this one is the information that is inserted inside the TCP header within a segment concerning all this information about the data. So application that uses TCP, okay, application means that in the application layer, what application utilize the TCP protocol? Okay, so the first one you can see that this one is HTTP. So HTTP is basically what application? Anybody know? HTTP.
Again, doctor.
Website, sir.
Website, yes, this is website HTTP. So FTP is file transfer protocol. When you want to transfer files, like for example, you upload into email or anything, you utilize file transfer protocol. And then you have SMTP, SSH. Okay, so SSH is secure shell. We want to connect to a location. Okay, and you want to communicate, you want to control a computer in a remote location. You are going to use SSH, and all of them will be utilizing the TCP protocol. Okay, next is for UDP features. Okay, so UDP features, they include the following. Okay, data is reconstructed in the order that it is received, and any segments that are lost are not resent. There is no session establishment. The sending is not informed about resource availability. So this is the features of the UDP. So you can see that here for UDP header, you have 32 bits width and 8 bits tall. So here you can add bytes tall. So here you can see that the header is much more smaller than the TCP, total of only 64 bits. Means that, okay, it can be sent faster, okay, and faster and more quicker than a TCP protocol. So all of this, okay, this is the header, content of the header within a UDP. You only have source port, destination port, length, and also the checksum. Okay, this is for the error checking for the checksum. So what kind of application that utilize UDP? So basically, they are usually used for live video and multimedia application. Okay, this application, they can tolerate some data loss but require little or no delay. Example includes voice over IP and also live streaming videos. Okay, if you look at into World Cup, live World Cup before, so most of them are going to use UDP. Okay, or even YouTube live, okay, they use UDP. So simple request and reply applications, okay, and then application with simple transaction where a host send a request and may or may not receive a reply, like for example DNS or and DHCP when you want to connect the Wi-Fi for the first time. Okay, usually they send request for DHCP. An application that handle reliability themselves, okay, like for example unidirectional communication where flow control, error detection, acknowledgement, and error recovery is not required or can be handled by the application, includes SNMP and TFTP. So try to remember some of the basic application involving UDP and TCP because it can be in the assessment later on. Okay. Next is regarding port number. Okay. So like for example, in the physical layer, you can see that we have the source MAC address and destination MAC address. And then in IP, in internet layer, you have IP address, source IP address and destination MAC address. But in the transport layer, you have source port and destination port. Okay, so the TCP and UDP transport layer protocol use port numbers to manage multiple simultaneous conversation. The source port number is associated with the originating application on the local host, whereas the destination port number is associated with the destination application on the remote host. So let's take a look. This is an Ethernet frame. Ethernet frame. So you look at here, you have destination MAC address, source MAC address, source IP, destination IP, source port, and destination port. And then you got user data, and then you got trailer. So this is an FTP connection. So file transfer protocol connection. Okay, the client source port is 1305. Okay, the sender is going to send it under 1305 and the destination is 21. So you're going to be into the destination under port 21. So 21 here is basically the door, which door they are going to use, okay, for entering your computer for your processing and everything. And in this case, down here for web connection, okay, you have different port itself, 1099, and also web server here, 80. Okay, the source and destination ports are placed within the segment, and the segments are then encapsulated within an IP packet. So the combination of the source IP address and source port number, okay, or the destination IP address and destination port number, okay, is already known as a socket. Okay, as a socket. Combination of IP address, source port, okay, and destination, source IP address and source port number, destination IP address, destination port number. Okay, this is known as a socket. You can, in the future, maybe you will find out that there are some applications that utilize this kind of socket. So socket enable multiple processes running on a client to distinguish themselves from each other and multiple connection to server process to be distinguished from each other. So these are what we call socket pairs. Okay, socket pairs. So IP address and destination, source destination and IP, and also source destination port. Okay, already known by the server itself. So port number groups. Okay, we have several port number groups. Okay, so we have well-known ports, we have registered ports, and then we have private or dynamic ports. So usually when we involve internet, okay, usually you have the 0 until 1023 ports. Okay, this is reserved for common and popular service and applications such as web browser, email clients, and remote access client. Okay, so definitely defined as well-known ports for common server application, and it enables client to easily identify the associated service required. Okay, so and then you have registered port. This one is for specific processes and application. Okay, and then for example, Cisco they has registered port 1812 for its radius server authentication process. Okay, maybe Google also have it. Okay, maybe your telecommunication network also have it itself. Okay, and then we have private and dynamic ports. Okay, here are we known as ephemeral ports. Okay, the client OS usually assign port numbers dynamically when a connection to a service is initiated. The dynamic port is then used to identify the client application during communication. Okay, so this is one of what we use. Usually, this is only within your computer's communication. So here are some of the ports, okay, well-known ports, okay. So for FTP, you have 2021, Secure Shell, you have 22, Telnet 23, and then you have a lot more port here. Okay, as you can know, as you can see in the university, some of your website, some of the website or some of the application, you cannot use them inside the university because of why some of the ports here are being blocked by the university administration. Okay, so if it blocks this port, you can no longer access any service through it. Like for example, if it's blocked 20 and 21, you cannot access or do any file transfer. Okay, because the file transfer usually they utilize 20 and 21 file transfer protocol. Okay, so how exactly do you know what port and what address to use? Okay, so port numbers, if you want to see the port numbers, okay, here unexplained TCP connection can pose a major security threat. Instead, okay, it's important to verify the connection. Okay, so here you can see that active connection in your PC. Okay, under which TCP protocol you have local address here, and then you have the foreign address here. Okay, and what kind of state this is established? Okay, this is mentioned here. Okay, next let's take a look at how TCP communication occurs. Okay, so each application process running on a server is configured to use a port number. Okay, an individual server cannot have two services assigned to the same port number within the same transport layer services. Okay, and an active server application assigned to a specific port is considered open, which means that the transport layer accepts and process segment address to that port. Any incoming client request addressed to the correct socket is accepted and the data is passed to the server application. So like for example here you have client 1 and client 2. Okay, and then here client request to TCP server. So here port 80, SMTP port 25. HTTP response source port 80, destination 49152. Okay, so here server respond to TCP client uses the destination port from the request packet as the source port. Okay, so destination port here 49152. HTTP request is for source port for this client one. So when they are established, okay, they will communicate directly toward this 49152. Okay, so you see that this one is source port 80 and this is also source port. Okay, what does it mean by these two area? This is source port 80, this one destination source port 49152, this one destination port 49152, this one destination port 80. Why does it opposite each other? Anybody can explain? Why is it opposite? Here, this one is 80 49152, this one 49152 80. Okay, anybody can explain why is it opposite? Anybody?
Because they communicate with each other.
Okay, 49152 represent what?
Represent the client server, the client one.
The client one, yes, correct. Means that this is a door towards the client. Means that when an application want to process data coming in to the client, okay, the data will come in through door 49152. So that's why it becomes source port. Okay, 49152. Okay, so when the server, okay, we have uh, he wants to send the data towards client 1, he will send through the door 49152. His mean that going out through 49152, okay, and in the client will coming in under door 49152. Okay, like for example, for client 1, when he's going to send out, okay, we're going under port 80, and then when HTTP, when the server receive, it will receive under door 80. Same thing for the MTP, okay, with their designated port for destination and also source both side. Okay, so let's take a look at connection establishment. Okay, so when A want to send data to B. Okay. So here you see that step 1, the initiating client requests a client to server communication session with the server. Okay, here is step 1, initiate. Okay, the A send some SYN signal here. Okay, so here he will send SYN signal and then B will acknowledge. Okay, the server acknowledge the client to server communication session and request a server to client communication session. Means that he acknowledge the request. Okay, he are going to give permission to A. What A also acknowledge, okay, that B already sent all those information. Okay, B already sent all those information. The connection is established and the communication begin. So you have to acknowledge to send the communication. And then that one is going for the start. Okay, we want to establish. And then once the finish, when the client has no more data to send in the stream, it send a segment with the finish flag set. Okay, I already finished all sending, send it towards the client. The client will send acknowledge. Okay, I have received the fin. I acknowledge the receiving of the fin. And then he will also send the finish signal to the A PC, telling that he will finish the sending and accepting as well. So and at the end, okay, A will send back the acknowledgement and both communication will be terminated. Okay, so just remember that when you want to send, you need agreement from the other side, and when you want to finish, you also need agreement from the other side. Okay, so here, then let's take a look at the three-way handshake analysis. So when we want a three-way handshake, okay, it established that the destination device is present at the network. It verifies that the destination device has an active service and is accepting requests on the destination port number that initiating client intends to use. It informs the destination device that the source client intends to establish a communication session on that port number. After the communication is completed, the session are closed. The connection is terminated. The connection and session mechanism enable TCP reliability function. Okay. So let's take a look at the analysis of three-way handshake. Okay, three-way handshake is what we call the process of acknowledgement. Okay, when it's sent, okay, receive, and then acknowledge, and then the other person acknowledge again, and then do the transmission. This is what we call three-way handshake. We have the 6 control flags. Okay, that is important here. Urge, act, push, reset, synchronize, and finish. Okay, so every time when it first requests, okay, it will upload data here. There will be a data being sent, a flag data being sent in the synchronize area. Okay, so this one is where is the control flag for synchronize? I forgot. I think it's yeah, in the control bit. Okay, And then you have, in case of acknowledgement, it will be a flag for acknowledgement. And then you have for pointers, okay, and then you have for reset, okay, and then for this one is incurs for urgent pointer. And then you have for reset, and then you have for finish itself. All of them is going to be signal under this control bit. Okay. Okay. Next, let's take a look at TCP reliability, guaranteed, and ordered delivery. Okay. So you can see that within a network, we have a lot of redundancy here. You see several networks. So in case a path route is interrupted, they can utilize the other route. Okay. However, the disadvantages is that when it sent, the order that it received can be not as what it sent. Okay, so in case this is data is going to be separated into several segments, and all this data is going to be sent, and they might arrive in not in orderly manner. Okay, and now here when the data being received by the TCP, okay, in the client, in the destination location, he will reassemble, rearrange all those data again so that it can be as what it sent before processing it in the application layer. Okay, so in case of data loss and retransmission, okay, so no matter how well designed a network is, data loss usually occurs. Okay, and then TCP provides method of managing this segment losses. Among these is a mechanism to retransmit segment for unacknowledged data. Okay, so here you can see that the data being sent 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you can see that here when he wants to send data, he receive 1, 2, and then 5, 6, 7, 8, 9, 10. So in this case, okay, he missed the 3 and 4. So he acknowledged that they are missing, and the data will be sent from 3 again. Okay, from 3 again, and it will send also the remaining part, so that this one is count as a duplicate segment. Okay, so this is where you have data loss retransmission occurs. So host operating system today typically employ an optional TCP features called selective acknowledgement, which is SAC. Okay. Oh, I only have 10 more minutes before it finish. Okay, so I'll give you another link for a break later on. Okay, so let's finish this one first. Okay, so when you have SAC, okay, so here you can see that they only send the missing one and continues with the one that are not available yet. Okay, so this is a typically particularly a selective acknowledgement. So it gives acknowledgement for parts that they did not achieve, and part that they did not receive, and parts that they have received only. Okay, and then we have TCP flow control. Okay, which is window size and acknowledgement. Okay, flow controls amount of data that destination can receive and process reliably, and flow control help maintain the reliability of TCP transmission by adjusting the rate of data flow between source and destination by for a given session. Okay, it means that they request the size of flow so that they can receive all the data properly when the communication occurred. Okay, here in case of maximum segment size, this one they will adjust the payload to code that this is the maximum. Okay, so that they can rearrange the header or any addresses so that the payload can be expand toward its maximum size. So, and then we have congestion avoidance. Okay, so here, in case there are problems, I'm not getting acknowledgement expect from PCB, so I will reduce the number of byte I send before getting an acknowledgement. So here he reduced the number while keep asking, and then here when it receive, it will send the remaining part that are problematic so far. And then for UDP communication, okay, so they no need to establish connection between before sending data, as I mentioned. So all the data being sent is, in case there are any error or any delays, they will just send it and they will not rearrange it in any of the order as it mentioned before. Okay, so for server process and request, okay, they are assigned well-known or registered port number. Okay, UDP receive a datagram destined for one of the ports. It forwards the application data to the appropriate application based on its port's number. Okay, so this is the process of the server process and request. And for client also similarly, you see that here, okay, you have source and destination. So source port is 53, destination 49152. However, for in this case, client, okay, they have 49152. They don't have a source port, okay, like TCP. Because why? Because when the client requests to the server, he will be only sending the data. He will not check for any acknowledgement. So they don't have a source port returning anything returning bad from the server. So there are no source port at the client. Okay, so far, okay, we finished for chapter 14. Okay, so because Google only allow here for 6 minutes. Okay, so let's take a 5 minute breaks. I will send you a second link for the next class, so please look into your WhatsApp so that you can join back the class later on. So I have to end this one first. Okay, so before we start a second session. Okay, so let's take a 5 minute breaks and please join again the class using the WhatsApp link.